one variable. For instance, f of x is equal to x squared. For now, we're going to talk about just the function of multivariate, just the several variables. For instance, f of xy is equal to x squared plus y squared over fxy and z is equal to square root of x squared plus y squared plus z squared, so on and so forth. So that's the functions of several variables. And the second section is the surfaces in space. But basically, we're talking about 3 dimensions of the space. And section 7.3 is about function of several variables. And in section 7.4, partial derivatives. What does that mean about partial derivatives? For instance, for f of x, this bivariate, or bivariate meaning bi is just there. See, bicycle, you have 2 wheels, bicycle. So bi, so it's bivariate, bivariate function. This is the, say, x squared plus 2xy. Okay, for instance. And since you have 2 variables, x and y, so you are able to take the derivative with respect to x or y. So here, take derivative, meaning differentiate, derivative with respect to, here's the with respect to what? With respect to x or y. So this is partial, that's the taking derivative. But since we only take derivative with respect to x or y, so it's partial. Okay, so it's partial derivative. Okay, when we take the partial derivative with respect to x, okay, what you have? So the notation would be, okay, you remember what we had before for the univariate, that's the notation for the derivative or differentiate. We use d, but in partial derivative we use rho. Rho is the related rho f of x, y, rho x. That's why we take the partial derivative of this function of x, y with respect to x. When we do this, basically, when you take the partial derivative with respect to x, we treat this as a constant. You can think of it as x squared. It's already 15 minutes. This is a derivative, is the partial derivative, right? So we can see this as the it's the x squared plus 2y and x. We treat this 2y as a constant. So the partial derivative with respect to x will be equal to the derivative for x squared will be 2x, and here there will be while. Okay? And similarly, when taking partial derivative with respect to y, then it be equal, because this is b, when taking partial derivative with respect to y, this would look like constant to y. So the derivative of constant is 0. Partial derivative with respect to y, right? So this will be you can treat it as a constant to y. So it'll be 0 plus 1. Now this will be 2x multiplied by y. So it'll be plus 2x. So it'll be 2x. So this is the answer. Okay? So it'll be the partial derivatives. And for notation, right? There's another notation you can write as the f of x of xy, or just simply f of x. And this one will be f of y, s of y of xy, or if you are sloppy, you can write it as f of y, just the notation wise. 50 minutes, not yet. Okay, and then we have the schema of functions of two variables. Okay, and we'll talk about it later. Okay. Okay, here. So for the first section 1, three-dimensional coordinate system, 三维坐标系. Okay. So you need to do is just make sure you know how to plot points in a three-dimensional space, and you know how to find distance. Okay, you know suppose there are two, you know the coordinates. For instance, 1, 2, 3, and 4, 5, 6. These two are these two are two observations of 2 points in three-dimensional coordinate system, or three-dimensional coordinate plane. So in the case, right, the distance, if there's A, there's B, you have 2 points, and the distance between the point A and point B is just doing that, find the coordinate wise. 1 minus 4 squared, that's x coordinate, that's y coordinates, that's z coordinate, plus 2 minus 5 squared plus 3 minus 6 squared. Okay. And the other thing would be how to find out the equation for sphere. Equation for sphere. Okay. There are a few ways to find it. We'll have to discuss it later. Okay. And then the last thing is to sketch the graph of coordinate plane. The coordinate plane trace of surface is a little bit, it's not quite easy to explain in plain English, but you think it's just like a contour map or label curve. You have label curve there, right? In the quiz, label curve. Right. Good. What? Hands up? No?
No. 10.
What?
You need 5 minutes.
And what? Oh,
10.
10?
Yes.
But let's check before 4 minutes left. How come now it's 10? In the three-dimensional coordinate system, okay, is the actually is known as the Cartesian plane. Cartesian is actually is I think it's French, named after a French mathematician. So Descartes plane, okay. So it also because it's determined by two perpendicular number line. It's just the what means is the xy coordinate plane. So because that's the rectangle, is rectangle. So also called the rectangular coordinate system. Okay, because it's the rectangle. Okay, here. In the three-dimensional coordinate system, here is the xy plane. This one will be green, and this blue one will be xz plane. Because the x-axis, this is the axis. The other one, this one is the. Let me show you. This is the y-axis. So this the pink one, pinky. Pink one is the xy plane, yz plane, and this green one is xy plane, this xz plane. Okay. So I actually I take some effort to create this kind of. I put some this sort of vocabulary in the most of pages. It's a accumulated list. So hopefully I hope it will be helpful for you. Okay, this one. So the three-dimensional coordinate system. So we have this taking pairs. So we have these three planes: xy plane, xz plane, yz plane. Okay. So because here you can divide by z when z is positive, right? You have you look at the z when z is positive. Z is positive, so you can think of just look at the when z is positive. So there will be x and y, so there will be four quadrants. But when z is negative, you also have four quadrants. So total are 8. 8, so we call it the octet. Okay, you have this one today too, right? We call it where? So it's octets. So we have 8 octets.因为我有八卦，哎，就是没事要说八卦。Okay, so the octaves. Okay, so here just show you just those three diagonal, the coordinates. X is the distance from yz plane to P. Okay. So suppose if P is here, right? P is there. If P is here, suppose P is here. Okay. So this would be this distance would be z. So what's fine? Z will be the right distance from this point P, and this distance will be the right distance from the point P to xy plane. And here, this distance will be the direct distance from the point P to what? To xy. The topic will be finding the maximum or minimum, which will be just the extrema of bivariate or trivariate, three variables function under some constraint. Under some constraint. Let's see, we learned this word, this term, this from last week. For instance, you can say x plus 2y plus 3z is equal to 100. You can think of, let's see, the say it's $1 per unit for Apple or something. That's $2 per unit for this product. Then $3 per unit for this. And you only have total $100. Under some constraint, you only have $100. You want to find the maximum, minimum of this function. Okay. But first of all, let's find the extrema of functions. Okay, and how to do this? You need to first of all find the critical point of the critical numbers. When you find a point such that what? The f sub x, the first partial derivative is 0, or the first partial derivative with respect to y is 0. Either one. Okay. Which is n. You need to have both equal to 0. Okay, then you need to find the matrix we call it Jacobian. The determinant of Jacobian matrix is it says here it's some kind of determinant function or something, because it's just d, find d. The symbol says just the d. D is equal to what? F of x multiply f y and minus f sub xy multiply f sub yx. Okay. Then what you have? Okay, so case 1, D positive. Okay, matrix is positive definite in the matrix sense. D positive and D positive and fxx is positive. So imply f a sub b is the relative minimum. Case 2, D positive and the second order of partial derivative f(x) is negative. I can imply f sub f of ab is the relative maximum. You can think of just in by your everyday case, right? You have a f prime is 0, say s prime x is 0. You see the 0 and f double prime x star with the positive. I can imply fx star is the relative minimum. Relative, or you can say it's a local. Same thing, local. And here, if the first derivative is 0 and the second derivative is negative, imply f of x star or f of x asterisk is a relative maximum. It's similar to the very case. Also in case 3, when d is negative. What's d negative? If d is negative, then I imply what? Imply a b f of a b is the saddle point. 安点。Okay. Case 4. D 0. And uncertain, you don't know what happened. Okay, second. Okay, just replace the whole thing a little bit. So here, we will find the maximum minimum for 2 or 4 bivariate function f x y. First of all, you need to find the critical point. Okay, find critical point. So you need to have a fx is 0, fy is 0. Okay, what was this? Keys lock. What happened to this one? You know how to this one, keys lock. Okay, so we just need to solve this one. First of all, find the critical points such that the first partial derivative equals 0, and then you find the Okay, so you find a quantity d such that d, you can use the capital D or lowercase d is equal to the second partial derivative f of xx multiplied by f of yy minus f of xy multiplied by f of yx. Okay, and then you will get there are four cases. The first two cases when the d is positive, when d is positive, you will have maximum or minimum. Depends on the second partial derivative f of sub x. If it's positive, you get the local minimum or relative minimum. If it's negative, you get the relative maximum. When d is negative, you get the 0 point. When d is 0, it didn't give you any information. And you can see that from here. Okay. This will be this way. This case is the f sub x is 0, s sub y is 0, and the f sub x is positive. You will get the local minimum. And this is you get when the first partial is 0 and the f sub x is negative, you get the local relative maximum. And that will be this point when the d is negative, you get the 0 point here. 0 point. Okay. I'm here. 0. Okay. Let's try this one. What's time? 3 minutes? Okay. Let's work on this equation a little bit. Okay. So I'll come back to talk about this again. So I want to find find the relative extrema or 0 points for this function. And I strongly suggest you to listen to this question very carefully, because the textbook it skips quite a bit of details for this question. Okay, so f of xy is equal to xy minus 1/4 x to the 4th power x4 minus 1/4 y to the 4th power. Okay, so first of all, set 0 equal to log f log x. So you get the first one you get, let's see, y, and here we get x cubed into 3 powers. And because taking partial derivatives with respect to x, so you treat y as a constant, so you get 0 there. Okay, also taking partial derivatives with respect to y, you'll get this x minus 5, x minus let's see, because it's the partial derivative with respect to y, so this will be treated as constant. Okay, x be treated as constant. So you get here will be y to the cube. Okay, and that's first equation, the second equation. From 1, I imply y equal to s to cube, and I substitute back into equation 2. Okay, so I substitute y equal to x cubed into this. So I imply what? Imply y, it's x. X minus s cubed to the cube, and that's 0. So this is actually equal to, I just need factor out, factor out x. I will get 1 minus 8 to the 8. So that's equal to x, 1 minus x to the 4th power, 1 plus x to the 4th power. So I get x, and 1 minus x squared, 1 plus x squared, 1 plus x to the 4th. Okay. So it's equal to x, 1 minus x, 1 plus x, 1 plus x squared, 1 plus x to the 4th power. Now here, so I have implied, so imply x is equal to either 0, 1, or minus 1. Imply, so I have xy is equal to 0, 0, or 1, 1, or minus 1, minus 1. I have these 3 points. Now, those 3 points are my critical points.